Hello. Hey. I am very nervous, but it will calm down in the middle. So yeah, thank you all for being here. This is going to be super technical, and I'm not going to apologize in advance. It's going to be a lot of code. There's like 85 slides of code. So yeah, so let's get to it. Oh my God. Why did you do that? All right, so game programming patterns for Godot. First of all, who am I? Because nobody knows who I am. I started studying mathematics. I wanted to be a teacher. Then back in Brazil, I did 2.5 years of math bachelor's. And then I went to try to teach. You have to do like an internship. Then I gave up because it's really hard. And kids just can't. Then I got a job as a dev. Then I went to study art for fun. Actually, take this off. Yeah. So, and then as also like I said, I was working as a dev and doing things as a dev and developing my projects, getting paid, and mainly it's a combination of those things. I also developed small games in the past, like this game that won a game jam, the Godot Wild Jam 21, a couple years ago, and also this a very simple game. And yeah, anyways, I'm working right now on a game called Tiny Drift, and I'm gonna use the code from the game. It's gonna be my first commercial release. It's coming out in October this year. So I'm doing as a solo Swiss Army knife developer, music, art, programming, everything, and I really love it. All right, agenda. So why do we need patterns? And I'm gonna show you the code. So why do we need patterns? So I believe that good code is code that ships. I really believe in that. That being said, I'm gonna use my own definition as a backend developer for 16 years at the moment. For me, good code is something that is maintainable, that's also readable, and most importantly, testable, right? You want to ensure that whatever you're writing, you can test and you can kind of predict the outcome of what you're doing. Cool. I'm also gonna mention domain-driven design, and I'm not gonna apologize for doing this. And if you don't know what it is, just ask me questions after. It's something very old. There are books about it. It's kind of standard in backend systems, and yeah, mainly also a lot of games use it, but I was very surprised that not a lot of people talk about this publicly. So yeah, if you have questions, if you never heard about this term, it's the first time, just reach out and yeah, we can talk about it. But I'm not gonna explain too much about it. It's just that I'm taking concepts from it and being very transparent about it, that I didn't invent anything here. The problem. So back to my game. I have these enemies flying around, and they have characteristics and stuff. And at some point, I had this big object called refs. It was an auto-loaded, a singleton object that has an enum. For some reason I did this, I don't remember why, it was a long time ago. And I also was preloading all the enemy scenes. And I was also on the same file keeping the weight, if I wanna spawn them in the screen and find which chance of them spawning. I was also kind of holding them in a different dictionary, right? So it's a big mess. And it was auto-loaded, it was referenced all around my code. It worked, the first version worked really well, but I couldn't really remember why things were done this way at some point. So I thought, okay, I need to change this. So I'm gonna talk about a little bit of the solutions, excuse me, and we're gonna refactor the code together. We're gonna discuss it, and we're gonna get to something that I think is really mind-blowing, in my opinion, about things you can do with GDScript that is not very publicly spoken about. So let's talk about data. So let's initialize data. So if you remember a few slides, I had this thing here, right? So I was preloading a bunch of scenes. And this was a bit messy for me. So first step for me was to initialize and get a list of things. So maybe some of you are familiar with this pattern. I'm gonna also give a disclaimer about it. There is a proposal already on Godot about this, so maybe it gets incorporated or not. It's called lazy loading. So basically you have cache and you want to compute a list of things. You call it once and then you save it on a cache and then you don't have to compute it again. That's it, right? For certain things in games, it makes sense to lazy load. For certain things, it makes sense to eager load. I'm not going to go deep into that because that's more performance things. But yeah, for me, it was important to build something like this. So basically, I came up with a little file that I call enemy repo. I'm going to talk about this in a moment. That I can, save the scenes and I can scan the scenes from the file system. That's very simple, actually. A lot of people do that already, but that was the first step for me. So I could remove all the preload from the reference files. Cool. That's the proposal, like I said. So it's, live. I'm not sure if it's going to be incorporated or not, but would be cool. I mean, it's very little boilerplate anyways, but yeah. The data, right? So I had these scene files. They were like repeating a lot of information about the enemies. So very basic stuff. I created a resource with a class name, and I created a bunch of resources, right? So that's second step. Very standard so far, nothing brilliant. And a bunch of information of the enemies, nothing really big. And the most important thing starts from now. So now we have the data, we initialize, we read it from the file system. We want to access it and we want to read it through the code instead of reading from a singleton or an autoload. And by the way, I'm not saying the autoloads are bad, right? But they start charging you rent at some point. And that's the problem. They were charging my code rent, and I didn't like that. So I got the same structure that I just showed, and I create something called enemy repo. Repo is a short word for repository. So I have a bunch of functions, and I'm going to talk about them. I have something called a getter, basically, by ID, which is the lazy getter that I just said. And it looks for the cache. If it's empty, if it's empty, populates it. If not, just returns the cache. Very simple. Then I get by ID. So I pass an ID of an enemy, which I'm using as a string name. It's not amazing, but it works for me. And I can just go to the dictionary and return that enemy. Very simple, right? And I have this enemy definition, which I just showed in a moment, like a few slides ago. I also have a function all that I can return all of them. So it's a dictionary. I can just do by ID.values. So it goes to the getter again, right? And then it gets the cache. If it not, just creates, and then get me all the enemies available. So that's already pretty cool. And I don't see almost anyone doing this or talking about this. So that's step one. Also, something that it's important to keep in mind, there is a function in this file called scan. We keep it for later. But if you can see, it just reads the file system, right? Just looks for it and initializes, and it's very simple, right? Returns a dictionary. But we're going to talk about it in a moment. So this is the repository. Repository, it's an abstraction over persistent storage that hides data access details by pretending all data is in memory. That's a really important definition. That's very nerdy, I'm sorry. And that comes from domain-driven design from Eric Evans. There's a book written in 2003, and it's pretty much standard for big enterprise systems or even small stuff. Let's see this in action now, right? So I have a spawner class in my level, or I don't have it anymore. So you can see here that I go to the singleton, to the global, to get array to type. I also to kind of create like a placeholder object. Then I want to do the weighted spawning, to calculate the chance, and then I also get references. I read the dictionary that I showed a few slides ago, and then I return something from the ref. So I'm like, it's a mess, basically, right? If the singleton, it's queued free or something, it's a mess, and I don't know what happened. Then I refactor it, and it looks bigger, and I'll explain why it's a moment, but it's way better. So very simple first step. I added the enemy repo, the class that I just showed, as a dependency, right? And you don't need to do it this way. I did it this way because I wanted to test in the editor. I still have it, and it's very convenient for me. But we're going to explore different ways to do it in a moment. And then I created a function that's called pick enemy that receives a list of enemies that I call pool and returns an enemy. Very simple, right? So the biggest difference here that I have references everywhere, and now I just take an argument and I give back another argument that is from the same type. So I'm respecting a lot of principles, and I'm using what I built, the repo, to pick and refactor my code and access the data that I'm reading on disk. So that's already I would say very good step that you can do in your code. And I would say that most of the time people do this, which is not, like I said, not necessarily bad. But once especially if you want to test your code, this is way better. And we're going to talk about this in a moment. And of course, I put like the code that calculates the weight. It's not important, so that's why it's darkened a little bit. Now the bread and butter, which is the actually really fun stuff. So let's say for some reason you want to load a JSON file, right? Instead of your TRES or whatever. Or there was a talk about YAML earlier. Let's say we want to use a YAML for some reason, right? I don't know, I also like YAML. But in this example, let's say you have an enemies.json file. Now you create a huge file called, which I did, called enemy repo.json. So I'm basically copying the same structure that I just created. And instead of reading from the file system, from the resource files, I'm reading from my JSON files, right? And I'm serializing data back to Godot, which is a very hard process to do by hand. I wouldn't necessarily recommend, and it can actually give a lot of problems, disclaimer. But if you're comfortable, do it, right? It works for me. So let's say now you load your enemies from a JSON, not from a resource file. What is the cool thing here is that because we're using this extension, the repos, the class that spawns enemy has no idea that you're loading your enemies from somewhere else, right? That's first step. If you are still using refs.mobs or whatever, or a singleton, and then you start loading JSON there, that would leak, that implementation detail would leak to everywhere you're referencing that data. But now because you are abstracted and encapsulated in a single class called repository, you can pretty much switch and have like, I don't know, an in-memory. You can test it, right? And I'm gonna show you how it's done later. So that's like really cool. Every implementation that you follow this and you just inject the dependency, the repository, you can pretty much change how you load the data on the background without paying any cost later. And your code doesn't know, and then you can test it in fully in isolation. So let's take this one step further. So let's say now you want to create an enemy source. So I found that I was repeating a lot of code already, and I created this base class called enemy source, and it has just a simple function called load all, and returns a list of enemies, pretty much, right? A list of data. Then I went there, and then I was like, okay, I have now the resource enemies, and I can extend that class and create a function that actually reads from the directory, right? So I can also use the editor to help me there to change the directory. For instance, let's say I want to have a drops resource instead of enemies. It can be a boss resource. It can be so many different things inside the game. Then I can also have a JSON one, and I can also use the export editor variables to point to a JSON in the data folder and serializes back to the game, right? And that's really cool because the repository code, it stays the same. It has no idea. You just need to inject the source. And then you can have many different sources from this. You can have JSON, you can have YAML, you can have in memory. If you're using GD Unity, you can use the same abstraction in class that you're using in game to test your code. You only have to change the source, and that's very simple. The implementations are the same. You have an init, because we're kind of doing like a lightweight dependency injection here. And basically, you have this function called load-all that you can see it was in the enemy source, right? You just have to extend and create new implementations of the class. Cool. Now, The cool thing here is that this allows me to have the same functionality. So I change a little bit the implementation, and I can just do like a lightweight dependency injection. So I can instantiate a new repository and pass a resource that's also a class, ref counted as new, and then I can have the enemies anywhere. It doesn't matter, right? They're lazy loaded, so it's very simple to use that. I can also have modding, maybe someone wants to use JSON for some reason. Maybe people want to mod my game. That would be amazing. I can also test my game. It doesn't matter, right? I can use the same implementation and I can feed another like in-memory enemy source, which doesn't exist yet, but I maybe will create it because it makes a lot of sense for me. And I can pass just fake data to it because I just want to test. Cool. So repository kind of answers how to find me the thing. So how do I get this enemy? But the cool thing that I also did is I wanted to find enemies that had certain characteristics, right? And I wanted to answer this question. So at some point, I had things like this in my repository class. So I want to have all the boss enemies for enemies with specific tags or characteristics that are inside the definition of the enemy object. And that can get really messy. You can like start adding methods, and a lot of games do that actually. That's a very common pattern. So enter the specification. So specification is also a domain-driven design concept that encapsulates a yes-no question about a domain object, which in this case are the enemies of the game, and encapsulates this inside its own class. And that's really important. And that's gonna get really technical, I'm sorry. So I have this spec file, and it's a class, very simple, right? It has a bunch of functions, and it has a function called matches, and, or, and not. And it also has extensions to itself. So there's a class end spec that extends the spec and re-implements a function that matches. And if you read the code, it's pretty much like a closure that says, okay, does this item matches this other item? If yes, returns. If yes or, it's very simple, right? So, but it's not a lot of, it sounds like a lot, but it's not a lot. And that allows me to do things like this, actually, to create a class that is called enemy specs, but it could be anything, like an item or anything that you can have in a game, and have things like this. For instance, a class hashtag that extends this spec, and then it looks for inside the enemy definition if that enemy, that data has the specific tag I'm looking for. I can look for which is the minimum wave in my game that the enemy can be spawned. So you can just write a little class that extends the spec and ask these questions, right? The implementation is very simple. Or you can also check if the enemy is a boss. Very simple. And then you can create this, and you can test this in isolation again, which gets to the point that if you go back to the repository, you can implement a little function called find here. And if you read it, it receives a specification that we just talked about and returns a list of enemies. And then again, very simple, goes to the dictionary, get the values, do a filter because it's an array. And then you can pass these spec.matches inside because it's a closure. And you wrote these callables in the other class. And then it's just going to return the list of enemies that fulfill the criteria that you want. And then you get into something like this, which is really cool. So you can find, I don't know, like I want to find everything that I can spawn in wave 5 of the game. So I can just write like enemies, that's the repository. I initialize it prior. And then I can run find on it. That's the function I just showed. You can have the specs, so like mean wave, so wave 5, and it's also not a boss, right? Or I can go crazy and say that I want the fire vulnerable airborne enemies, whatever this means. You can also, again, do a find, do all the specs in line, and you can pass them, you can chain the methods, right? You can do this in GDScript. That's method chaining. It's a functionality that many more modern and also old programming languages have it. And then again, you get the results. Or you want to, I don't know, maybe you have elite mobs on your game and then you want, for some reason, in certain wave, in certain moment of the game, install the elite mobs. That can be done very simple, right? And the repository is where the things live. Oops, sorry. So the repository is where the things live. And I understand that I'm not coming from the game development background, so those things come very natural for me. I prefer to go this route. But if I think about data, I want the easiest way to read it, right? That's why I built these abstractions. So if you want to think about what is a repository, is where things live. Also, a good pointer on this as well is that if you come from the database world, if you work with databases in the past, if you know the concept of ORMs, object relational mapping, this is exactly what an ORM implements. This thing here. These things here. So it gives you a type of language that abstracts how you find your data, so you don't have to write the, let's say, low-level code. So that's what like object relational mapping libraries do for you, and they are very popular in the backend world. Actually, you don't start a project with a database without it, actually, because it's super hard to do it on your own. So you don't want to do this. And going back here, so yeah, repository where things live. The specification is how you ask about them. So what are the criteria, right? And if you reflect about, if you're also like coming from the regular software development, you want to do a SQL query, it's the same concept, right? You ask certain characteristics on the query, and then you give certain parameters, and that's exactly the same format. You don't have to use it to use those together. Absolutely not. You can use one or the other. They are composable. They are interchangeable. You can pretty much, choose whatever is, Also, you don't need to use either of these. I went like a good amount of time without using anything until I found out that, oh my God, it's too much. And it's a very small game. Think of like a tiny query language that you're building for yourself that is testable, and it's like abstraction on top of something that Godot offers you already, right? If you think about Godot and Godot resources and the file system, it's kind of like a database already, right? There's a lot of functionality for you, but like I think most of the people don't really see data like that. But if you build it in the way, you can extend and just describe to yourself, okay, I want to find items, I want to find enemies, and you can actually make this available to every other layer of your game, right? It's a repository lazy loaded, so you can just use UI for that. You can actually spawn the physics enemies in the code, right, or in the level. So you can really abstract things with these implementations. And yeah, and then if I would like to have like a takeaway from this talk, right? Don't ditch the autoload. It's actually really nice. You have to have singletons. They're really cool. Yeah, I think we overuse a little bit, but all good. We still have time to be saved. But reach for it when the autoload kind of starts charging rent for your code, that when you feel like, hey, actually, I cannot progress here. I don't know why I want to test my game, or there's this bug that's happening on the play tests. Think about patterns. Think about what can you abstract and make your life easier, and try to critically think when to implement something instead of just doing because I told you to do it. Even though it's very easy, you should do it. I recommend. And that being said, thank you so much. Yeah. And those are some links for my socials. I figured out that I had to add this on the last slide, and I didn't have it until today. So if you want to wishlist my game or message me on socials, it's all there. Have fun. Yeah, I don't know if we have time for questions. Yeah, we have 5 minutes, so we have certain questions, and feel free. If you have questions, don't make them really hard, please. Ooh, Eric is really working hard.
Hey.
Hello.
Nice solution, like to not have auto-load singletons. However, we need to access those repositories from multiple different places in the game, right? So how do you solve it? Like you create separate repositories, but then how do you think to have like the same source for everyone? Or do you have some global after all?
I mean, I like I said, I don't tell people to ditch globals or autoloads, right? Absolutely not. In my case, I load them as a node. That's it, right? I know the repositories as a node. And that's why I was using editor exports everywhere, because I can easily swap nodes and data. That's how I do it. But there are probably many different ways of doing it. Yeah, like at the moment for my game, I don't think too much about the performance of accessing the data, even accessing at some point again, you know, if I have to, because it's not a price I pay. I pay more for the productivity of like being able to develop and test. But it's a very valid question, and that's how I do it. At the moment, I don't know it's the best way of doing it. It's the way I found how to do it with Godot. So I just have like a node in the root scene, right, that never goes away after it's lazy loaded.
Yeah. Okay, makes sense, thanks.
There were like a few questions here. Or?
Hi. Obviously, this is going to get more and more complicated as you add more parameters. Did you ever consider something like Godot's SQLite extension?
I have no idea what you're talking about. Maybe I should research it. But it sounds really cool, I guess. I mean, I'm also a SQLite user, so probably it's something I would benefit, especially I can imagine this kind of system being very good for card games, for instance, which you have like huge amount of resources and maybe you don't want to do everything in the editor, you know, stuff like this. And then you just build this realization and use the repo to load. But it makes a lot of sense, right? You can probably, yeah, I'm going to research that. I had no idea it existed. Do we? Oh, cool. One more. Oh, you sound like you're going to make it hard for me now.
First of all, compliments for sitting in front of a room of game developers and talking about architecture.
Oh my God, yeah. I thought about this actually. I was like, oh, what the hell I'm doing?
Very brave. I'm really like the style. My question is, you talked about testability when you started off. Do you unit test your games?
Absolutely.
Awesome. Can you tell me more about that? How do you do that?
I mean, wait. So this here, like I literally use these functions on my unit test, and I can actually, if you add me on Discord, I can send you my code of the test. Like I don't mind, really. And after my game is out, please decompile my game and check everything. Like this is how I test actually here. Like I use this, like something like this. I just don't use the in-memory enemy source, but that's the structure I use on my test. So like I run the cases, and before running the cases, I create a new repo with a data. That's it. I use this actually. But you should unit test your code. It's very simple and very easy. Say it again? Yeah, true. Well, yeah. More questions? Go for it, Eric. You're doing great.
Thank you for your talk. I had a lot of fun. I've had several of the issues you describe and you fix, and I kind of fix them the same way you do. But no one can read them sometimes, not because of the way I define them. It's mostly about, you know, we don't do it like this, so why are you doing it? And I have, I taught Haskell for quite a while, so I know a lot of functional programming, and I find that it's very useful in a lot of like data managing cases. I was wondering if you see Godot implementing more functional programming in like there's Lambda functions, but more niche. And if you find that there would be an audience which we can teach to use.
Yeah, that's an absolutely great question. There's, first of all, it's a long time since I contributed to the source code. It was like Godot, was still Godot 2, so really I don't touch the source code to contribute. So I don't know exactly the direction things are taking at the moment. I personally would appreciate more of it, for sure. I mainly work with Golang and Rust. Yeah, like in Golang, it's not necessarily a functional paradigm, but you can do it, of course. I do think that things like chaining methods, currying and other things could be really cool to be implemented in GDScript. And the ergonomics are very loose in a way in GDScript that allows you to do it, So that's kind of nice. That allows me to do stuff like, like this, which just looks weird, but actually the ergonomics it's actually kind of nice, It looks weird like reading here, but it works really nice. So I think I think there's an audience because data-driven games, they can actually get a lot out of these systems, things written this way. Then you just declare the data, and then the way you access it is very declarative, right? But you also have imperative methods and stuff. So I would really appreciate, until it happens, I would just create my own, I guess, stuff like this. And also if you, I worked a lot of JavaScript libraries in the past, they also implemented chaining methods, and I took a lot of these ideas from there too, by the way, because I used to work a lot with it. So I basically just look at those, ergonomics, those methods, the constructors, how can I do it similarly, And I personally felt like this was for me a game changer, being able to describe the methods the way I describe the data too, And yeah, I think there's an audience. I'm surprised that not a lot of people talk about this publicly. That was something when I was writing the talk. And I'm really sorry I don't have a write-up on this. Maybe I'll do it one day. Maybe I can share all the code. But when the game is out, like I said, they compile and see how it's done. So yeah, very simple too.
Well, thank you. Give him all hands.
Thanks.